Now, we'll come to this later. I'll show you something more. Okay. I found the remainder. The question actually was finding the remainder. Okay. Find the remainder in this following case. So the remainder is 0. Okay. We got that. Now, we'll come to this later. I'll just show you something else. See this. Normal division I have shown with numbers. Okay. The first division is I have divided 25 by 3. 8 3s are 24 and it gives you a remainder 1. So is 3 a factor of 25? Okay. Is 3 a factor of 25? Okay. 3 is not a factor of 25 because what is the remainder that you are getting? You are getting a remainder which is 1. Okay. So 3 is not a factor of 25 because the remainder equals 1. Okay. Now how do you know whether something is a remainder? Is if it gives a remainder which is 0, then this becomes a factor. In this case it gives a remainder 1, therefore this is not a factor. Let's see this division. I have divided 25 by 5. Okay. 5 5s are 25, remainder is 0. Okay. In this case, since the remainder is 0, is 5 a factor of 25? Because the remainder is 0, 5 is a factor of 25. So I have written here, since remainder equals 0, 5 is a factor of 25. So you come to know whether something is a factor or not by looking at the remainder. In this case the remainder was 1, therefore 3 is not a factor. In this case remainder is 0, therefore 5 is a factor of 25. Okay. Coming back to the previous one, I said, see this one, I said till here, starting from here up to finding the remainder is called the remainder theorem. Okay. Again, as I told you, when the remainder becomes 0, then you know something is a factor. Okay. In this case we divided by 2x plus 1 because the remainder is 0, so 2x plus 1 becomes a factor of this expression. Okay. So I have written here, since remainder equals 0, 2x plus 1 is a factor of 2x cubed minus x squared minus 3x minus 1. That was the polynomial that we divided. Okay. See this? Till here I said was the remainder theorem. Because of this extra step, okay, where I have written, since the remainder equals 0, this one becomes a factor. Now this whole thing becomes factor theorem, including the remainder theorem. That last step which is there says that something is a factor, the whole thing becomes factor theorem. Till here it's called remainder theorem, including this step it is called factor theorem. Okay, so that's the only difference between remainder theorem and factor theorem. Okay. Let's go on to the next one. This is question 16 from exercise 9a. Prove that x minus 2 is a factor of x cubed minus x squared minus 5x plus 6 is the question. Okay. This is the polynomial that you have to divide and you have to prove that this is a factor. To prove that something is a factor, you have to see that the remainder is 0. So all that you have to do here is, the procedure is the same of remainder theorem. You find the remainder, see whether the remainder is 0. If the remainder is 0, then x minus 2 becomes a factor. Okay. So starting with this, let x minus 2 be equal to 0. Shift the minus 2 that side, x is equal to 2. Okay. Put this value of x in the polynomial. So this is the polynomial which I have written as p of x is equal to x cubed minus x squared minus 5x plus 6. Okay. I am going to substitute the value of x. X is 2. So p of x is 2 is equal to x is 2 whole cube minus again x is 2 whole squared minus 5 into x value is 2 plus 6. Okay. This should give you the remainder which I have written as r. So r is equal to 2 cubed is 8 and then minus 2 squared is 4 and this gives you minus 10 and plus 6. Okay. If you simplify this, 8 and 6 gives you 14, minus 4 and minus 10 gives you minus 14. This 14 minus 14 gives you a remainder which is 0. Okay. Now that you know the remainder is 0, you can say something about x minus 2 using factor theorem. That is, x minus 2 becomes a factor because the remainder is 0. So I have written, since remainder equals remainder equals 0, x minus 2 is a factor of this expression. Okay, that's what you need to prove in this question. So we got remainder is 0, therefore x minus 2 is a factor. Okay. Next question is question number 6 in the same exercise. Okay. Find the value of a when the expression, this is the expression given, x cubed plus x squared minus 2ax plus a squared has remainder 8 when divided by x minus 2. This is the polynomial and it is divided by x minus 2 and it says the remainder is 8. Okay. Procedure is the same. You will start with x minus 2. Let x minus 2 be equal to 0. Shift minus 2 that side. X is equal to 2. Okay. This is the value of x. The polynomial is this, which I have written as p of x is x cubed plus x squared minus 2ax plus a squared. Substitute the value of x. X is 2. So this becomes p of x is 2 is equal to x value is 2 cubed plus this becomes 2 squared minus 2 multiplied with a into x value is 2 plus a squared. This gives you the remainder, r is the remainder, equals 2 cubed is 8 and 2 squared is 4 and this together gives you minus 4a plus a squared. But if you look at the question, the remainder here is 8. So this r value, which is the remainder, is 8. So r becomes 8 is equal to whatever is here I have written, same thing. This 8 and this 8 can be cancelled. That's gone. This 8 becomes 0. Okay. Now rearrange this, you will get a quadratic equation. So the first term is a squared, second term is minus 4a, and then plus 4 is equal to, I said, 3, left over here is 0, equals 0. Okay. So this is the quadratic equation that you got. Split the middle term. Okay. So you're supposed to get a product which is 4, sum which is also 4. So that gives you a squared minus 4a can be split as minus 2a plus 4 is equal to 0. From here a is common and a minus 2 is left. From here minus 2 is common, a minus 2 is left, equals 0. Out of these two terms, a minus 2 is common, that's removed, and whatever is left is also a minus 2 equals 0. Therefore, a's first value from here is 2 and a's second value is also the same, that's also 2. Therefore, you get one a value, therefore a's value is 2 here. You don't have to write 2 twice, okay, because both values are same. So a's value is 2. Okay. So this is the first part which we've completed. Okay. Go through this carefully and I've given you some homework. The homework is exercise 9a. Question numbers are 1, 18, 19 and 20.